Hello and welcome back to Precalculus1, Chapter 7. We are solving equations. Linear equations, nonlinear equations, systems of equations, and if time permits, we are going to look into partial fraction decomposition, which is extremely important for your Calculus 2 class, and differential equations later on. All use that procedure. It's a procedure. So at some point in life you learned completing the square and you use it in PreCalc. So now you will probably, if we get time, learn partial fraction decomposition eventually to use it in your later coursework. So, systems of two linear equations. This is the review from whatever you learned in algebra. So zero new stuff here. You have two equations given to you. Say a x plus by equals c and dx plus ey equals f. And these are two linear equations. So when you have two linear equations, possible configurations are that those two equations intersect. And creating that intersection xy, the point, would be known as the one, or well, I'll just call it solution. So it's a one unique solution. The lines could end up being parallel. If you have parallel lines, they never intersect, in which case we have no solution, because they don't intersect at any point that we see. And then we can have one line, well, maybe I should, let me just line 1, line 2, line 1, line 2. And the third case is when these lines go on top of each other, so line 1 and line 2 on a pile, and that's when we have infinitely many solutions, because these lines intersect at every point, so at infinitely many points. So infinitely many solutions. So these are the situations that we have. Now, for this case, the first case, we can use, well, for all the cases we can use algebra, obviously. But graphing is the first thing that you try and to learn, but graphing is not practical at all, because you have to be really, and I mean really precise, in order for it to work. Alex.
Professor.
Alex. Here's your exam.
Thank you.
Survive. All right. So let's. So you don't really want to use graphing, because you have to be very, very precise with the execution of the problem. Otherwise, the lines are not going to intersect at the point. Also, if it turns out that the lines intersect, you know, away from what you would consider to be, you know, nice point, as you would say, it would be difficult to read the decimals and fractions off of the, you know, the graph. But I can try. So x plus y equals 7 and x minus y equals to -1. So this is a system of two equations, and you guys learned how to deal with this in algebra course. The reason why we are reviewing this is because the next section is 3 equations and 3 unknowns. This is a review. To be upgraded later eventually in life into infinite, if you want to. Anyway, any size. So we start by graphing these two lines. Since they are given in standard form, line 1 with its x and y intercepts, we get 7 and 7. Because when x is 0, y is 7. When y is 0, x is 7. So we can graph the first one at 7, 7. Seven, 7, and then we connect these two. And then for the line 2, so this is our line 1. For the line 2, we also have standard form, so we are going to do 0, 0. When x is 0, y is 1, right? Because you have negative y equal negative 1, so y is 1. And when y is 0, x is negative 1. So negative 1 on x and 1 on y, and then we go like that. And that's our line 2. If you did this with enough dose of OCD, what you get there is the solution, which you can read as 3 and 4. So we get unique solution 3, 4. Now you can check that, and you check it by 3 plus 4 is 7 and 3 minus 4 is negative 1. So it checks in both equations, which means that's the solution. We don't use graphing method to figure out these precise values and so on, because most of the time it's going to be decimals or difficult to read. So we have algebraic ways to deal with this, right? Calculations, and those are, anyone remembers? Very good. Substitution and addition method. So they're different creatures. I will solve the same problem using both of these methods, and then you will decide which method is, well, some methods are more appropriate than others in different situations. So you want to, you know, pick your poison. So here we go with 5x minus 4y equals 9, and x minus 2y equals negative 3. Now I'm going to solve the same system using the other method as well. And we'll see. Generally, I place this line under the system every time, so I know that I always have my pair. If I am modifying one equation and copying the other, I still write both of them because they are pair. So, to work on substitution method, hopefully you remember that you are supposed to locate a single variable. So out of 5x, 4y, x, and 2y, the only single one is x. you solve for it. So from this equation you would say x equals 2y minus 3. You move 2y to the other side. And now you plug in. You plug in the other equation. So you're replacing x. So this is 5 times, and instead of x you have this 2y minus 3 business. And then you have minus 4y equal to 9. 10y minus 15 minus 4y equals to 9. Observe that this equation now is in terms of only one variable, y. 10 minus 4, that's 6y, equals to, move 15 to the other side, becomes 24. And there's your y equals to 4. You plug that now into the x equation, and you have your x. So x is equal to 2 times 4 minus 3. That's 5. Ordered pair. So 5, 4 is the solution of the system. So this is a substitution method, review of substitution method from algebra. All you do is you solve for a single variable, and then you plug in the other equation. You grind through the algebra that you see, you calculate one variable. As soon as you have one, bring it to the substitution equation and calculate the other. Very straightforward. Now, on the other side of the line, you have what we call addition method, also known as elimination method, also known as Gauss-Jordan elimination, also known as, it has a lot of names because it is the universal way that always works. See, what happens if you do not get a single x or a single y for substitution method? If you force substitution method, you are going to work with fractions. Now I know how much you love fractions. So, we have a method that works 100% of the time and no fractions. And that will be the elimination method. The elimination method is going to ask you to make coefficients of either pair of variables additive inverses, which means same number, opposite sign. So when you add them, they annihilate each other. So I can make, that's 5x. I can multiply bottom equation by negative 5, and then I will have 5x, negative 5x. When I add them, they are gone. Or, which is my preferred thing to do, multiply bottom equation by negative 2. I'm multiplying by a smaller number and getting smaller numbers. You can do that. It's fine. And you can multiply both equations at the same time if there are no easy common things to work with, like 2 and 4 and so on. We'll see that as well. So my preferred way is to multiply, for this case, is to multiply by negative 2. Observe that I'm copying the first equation. Because I'm not working on a first equation, I copy it as is. And the second equation gets negative 2x plus 4y equals to positive 6. Generally, your mistakes are here. You forget to multiply this number. I don't know why. But that's what generally the mistakes are. And now you add these two, which will eliminate, hence elimination method. Or you add equations, hence addition method, right? So when you add these two, this 4y and negative 4y cancel out, and you are left with 3x is equal to, when you add these guys, 15. From where x is equal to 15 right away. I mean 5. Pay attention. So x is equal to 5. And now what you do is you plug that 5 in any of the equations above and compute y. So I will use the second equation. So from the second equation I have 5 minus 2y is equal to negative 3. So 8 is equal to 2y, y is equal to 4, and there it is, 5, 4 again. Obviously you have to have the same solution. It's the same problem. So now you see both problems side by side. And guys, it's not a competition which one is shorter, which one is better, which one is... No, it's not a competition. What you have over there is simply one method is easier than the other. In this case, both are kind of the same. And actually I use both of them, whatever is faster. But one thing to keep in mind is that if you do not have a solo variable, like we have x in the second equation, your elimination method is the best bet, because you are guaranteed to have fractions if you use substitution there. So here is the example for that. You see 3x, which is the last example for this review. 3x plus 2y is equal to 48. And 9x minus 8y is equal to negative 24. So you're looking at this, and substitution method is absolutely out of question. Any one of these variables you pick for substitution will introduce fractions in some form somewhere. And we are lazy, so we don't want that. What would be the preferred way to solve this? What do you think? Multiply by 4 on top. Any other ideas? Yeah? Negative 3 on top. All right. So those are the two choices that I've seen immediately. And to be honest with you, I can't really pick my favorite, because 4 is positive, so we don't have to worry about negative signs, but then negative 3 is a smaller number. So work with lesser numbers. So they both have something good about them. So which one should I choose? What do you guys collectively think? Negative 3? You want to see the negative signs? All right. So negative 3. All right, fine. So that's going to be negative 9x, negative 6y is equal to negative 3 times this 24, negative 144. And then 9x minus 8y is equal to negative 24. 9x and 9x, when I add the equations, will cancel. So we can strike that out. And I have negative 14y is equal to negative 168. So y is equal to half of 168 is 84, so 10, 12. So y is 12. And now that I have y, I can use any equation. So I got 3x plus 2 times 12 to be 48. Now you can see it's 8 from here, but 3x is equal to, this is 24, so 24, and there's your x equals 8. 8 over 12, 8 comma 12. Now, there is a cheap and easy way to see if we have any of the other two cases where you have either no solution or you have infinitely many solutions. And those methods all involve spotting that the slope is the same. If you look at my pictures over here, line 1 and line 2 in both of these have the same slope. So you can quickly spot problems that have no solution or infinitely many solutions by simply looking if the two equations given to you have the same slope or not. So if I give you, let's say, example 2x plus y is equal to 9 and 2x plus y is equal to 8. Well, this system has no solution. And that's obvious immediately, because if you are to multiply one of these equations by -1, everything on the left will cancel, and on the right you will get 1, so it will be 0 equals to 1. You see that? So if you multiply bottom by -1, you will have 2x plus y equals to 9, and negative 2x minus y equals to -8. When you add them, what do you get? 0 equals 1. So these lines have the same slope of -2. But they have a different y-intercept. So if you have two different y-intercepts and you have the same slope going through it, through those intercepts, clearly they cannot intersect. So no solution. And the situation for infinitely many solutions is when it's the same line. Usually those are in disguise. Say you have 3x plus 5y is equal to 1, and you have negative 9x minus 15y equals to -3. And this is given to you as a system. Well, you would say, well, let me multiply the top by 3. And as soon as you do that, you see that everything cancels. So you have 9x plus 5y is equal to, 15y is equal to 3. And negative 9x minus 15y is equal to -3. When you add these guys, you get 0 equals 0. Now that's the true statement. Right? 0 equals 1 from the previous example is not a true statement. Therefore, right, you don't get to have a solution. But now you have infinitely many solutions because this is a true statement, and whatever points lie on these lines are the solution. So this case has infinitely many solutions. And that's that. So this was the review of what you know, what you're supposed to know from your algebra class regarding these equations. The next step in evolution is to talk about 3 equations and 3 unknown. And there is a very systematic way to deal with this, so you don't run into those infinite loops and then start breaking things because you don't get to solve it. So let's take a look at those. We'll restart the stream.